By the end of this class, we'll be able to explain what computer networks describe the components of network to guide informed decision. Somebody say my voice is not audible.
Yes. Yes, I can hear you, but it's not that audible. I have to put the device close to my ear.
And I didn't want to shout. Okay.
So it's okay, sir.
Design different layers of network architecture for resource sharing. Design and implement the different types of communication. So let me disconnect the Bluetooth and maybe talk directly. That may be
okay. Babe, can I use your earpiece?
You that you just see.
I'm with you, sir. No.
Be quiet. Be quiet. I think we're going to be.
Everybody seems to be down.
Can you hear me?
Yes.
Good.
It's clear now, sir.
Okay. Data communication. The term telecommunication, what it means actually is communication from a distance. And the word data refers to information presented in whatever form that is agreed upon by the parties creating and using the data. And so data communication, what we mean by it are the exchange of data between two devices through some form of transmission medium, such as a wire, cable, or wireless. And when it is taking place, delivery must get to the correct destination. Accuracy, the data must be accurate from when it was sent up to when it will be received. Timeliness, there must be real-time transmission. What we mean by real-time transmission is that the data as it is created and shared, it must be instantaneous. Jitter, uneven delay, must not even be tolerated. And so we look at the components of a data communication systems, and there are actually 5 components. We talk about the sender, we talk about the medium, we talk about the receiver, the protocol, and then of course the message.
So they will feel like they're actually making.
If I am the host, gentlemen, we are going to have tests now.
The 5 components of the data communication network, they are 1, the message you are going to send. 2, the person who is sending the message. 3, the person who is receiving the message. 4, the medium through which the message will pass. And 5, the protocol or rules that guide how the message should be created and transmitted. These are the 5 components. So in every data communication system, you have the message itself. What do you want to send? Maybe you wanted to send a Christmas message to someone. Who is the sender? You are the one that created the message. You now use your computer. Then from there, you are going to pass it through a network, maybe the internet. That becomes the medium. It gets to its destination. The person who will collect it is now the receiver. Then by the time the message is leaving your computer and going to the other computer, it has to be formatted from digital to analog and vice versa. So it has to conform to some rules. That is where the protocol comes in. And then the message will leave, get to its destination, and then the person there will receive it, read it, and communication is complete. And the data we are trying to send could be in form of text. numbers, images, audio, or video. Could be multimedia. Bundle all of them together, you can actually send them out as data. So we look at the way the data flow. It can flow in 3 different modes. It can flow as simplest, where the sender sends out the data, it gets to its destination, the receiver receives it. But the receiver cannot reply back. The sender can keep on sending the messages. It's not possible for the receiver to reply back. Example could be a radio transmitter. They are broadcasting from the radio station. They send. It gets to where you are, you receive, but you cannot communicate back immediately and tell them, I couldn't hear what you were just saying. The second one is half duplex. Here, the sender will be sending the message. The receiver will receive. But immediately the sender is sending, the receiver cannot transmit. As long as the sender is sending, the receiver will be quiet and be receiving. When the sender finishes sending, the receiver can now start replying and the sender will be quiet. Example would be your walkie-talkie. 2 of them cannot talk simultaneously. That is how the walkie-talkie behaves. The third one is full duplex, where the sender and the receiver send their messages, respond to it, interact with it simultaneously. Can interrupt the receiver, can interrupt the sender, just talk like that, and the message flows uninterrupted. So that brings us to the concept of a network. A network is a set of devices or nodes that are connected by communication links. A node can be a computer, it can be your mobile phone, it can be a printer, or any other device that is capable of sending or receiving data generated by other nodes on the network. When you connect your device, for instance, your phone, maybe to the internet, you actually are connected to a network. Other phones that are on the internet can see your particular phone, can interact with it, and you can actually send messages to those other phones. So in most cases, the type of connections we have are point-to-point, multi-point. We just look at it. When you say point-to-point, you have a dedicated link which is provided between 2 devices. They can communicate continuously among themselves. When you say multi-point, more than 2 specific devices can share a single link. We have this one already present in our environment. Then we also have to look at the word topology. Topology is different from network. Topology here means the way the computers or devices in a network are arranged, actually arranged, the shape they form when you arrange them. And based on this, we have 5 particular types of topology we'll be looking at. We'll actually give example. We have the mesh, we have the star, we have bus, we have ring, and we have tree. Mesh, star, bus, ring, and tree. Mesh topology. If you look at it now, you see that they are all connected to each other like that. Every device has a dedicated point-to-point link to every other device. Dedicated links carry traffic only between the 2 devices it connects. And a fully connected mesh network has n into n-1 over 2 physical channels to link n devices. Every device on the network must have n-1 input-output ports. The advantages of mesh is that it attracts less traffic. It is robust. It is very secure. And it is easy to maintain. Disadvantages, it needs more resources, cable and ports, and is very, very expensive. Then the second one, which is very popular, is the star topology. You can see that it's arranged in the form of a star. Here you have a hub at the center. Other computers can connect to it in form of a star. So each device has a dedicated point-to-point link only to a central controller, usually called a hub. This central controller can be a central computer. It can actually be a server. Every other device connects to it. And no direct traffic can link between the devices. So if a device wants to connect to another device, it must go through the controller or the hub. before it gets to another device. So if A wants to communicate with B, A has to pass through the hub before it gets to B. Advantage is very less expensive. It's not that expensive to install. And it is easy to install and reconfigure. And it is robust. Disadvantages, single point of failure. If that particular hub fails, the network collapses. It doesn't work again. And that becomes the end of it. So some persons may actually use mesh. Some may say, no, I don't want to use mesh. Let me use TAP because I think I can afford it and it is very okay. Then the bus topology seems to be very popular. Here you have a long cable that is there, and then other devices can connect, tap from that cable and connect to it. These other devices can be a computer, can be a printer, can be a mobile phone, can be any other device. It's a multi-point topology. That is multiple points. All the devices are linked through a backbone cable. That is the name of that long cable. And the nodes are connected to the bus cable by drop lines and tap. A drop line is a connection running between the devices and the main cable. So you have a tap, a connector that either splices into the main cable or punctures the sheathing of a cable to create a contact with the metallic core. Advantage of bus, very, very easy to install. That's an overall advantage. Disadvantage is difficult reconnection and fault isolation. If you have problem with one particular device or the other, it's very difficult for you to check for that device to isolate the fault. Broken or for any breakage or fault of the bus cable stops all transmission. If that particular cable you call a backbone has a problem, assuming it fails, then the bus topology crashes. It no longer works again. Then you have the ring topology. The ring is just designed like a ring, where all the computers are connected in form of a ring, one to the other. Each device is a dedicated point-to-point connection, only with the two devices on either side of it. Device A can connect with B and C, as the case may be. So a signal is passed along the ring in the direction from device to device until it reaches its destination. Each device in the ring incorporates a repeater. The repeater is the one that helps it to broadcast the signal from itself to another device, as long as those signals are not meant for it. Advantages, relatively easy to install and reconfigure. Fault isolation is simplified. You easily know which of the computer has a problem, and then you can simplify the fault. Disadvantages, unidirectional traffic. What do you mean by unidirectional? The traffic flows in one direction. But nowadays, we have a bi-directional ring topology where it can go back and forth. What it means is that if in a ring topology, one of the nodes fails, then every other node after it will not receive communication from the node before it. That is for the unidirectional version. But for the bidirectional version, that is simplified. If a particular node fails, it can reverse and start going through the other direction to communicate with the other. Disadvantage is unidirectional traffic. That is for the simple ring. The complex ring now has bidirection, which is better. Free topology. It integrates multiple topologies together. It can integrate multiple star topologies together onto a bus. You have a bus, different stars come together. It forms a tree. The reason why it's called a tree is that you may have a cable, other cable flow from it, and then they can expand. Advantages, point-to-point wiring for individual segments. Is supported by several hardware and software vendors. Disadvantages, overall length of each segment is limited by the type of cabling used. If the backbone line breaks, the entire segment goes down. More difficult to configure and wire than other topologies. So because it's using a backbone, if it breaks down, it means the other segments will no longer be able to communicate with each other again. And that becomes the end of the journey. We could also have a hybrid topology where any of these 5 methods we have mentioned can come together, 2 or 3 of them can be put together to form what you call a hybrid. In the hybrid, a tree can be combined with a star. A bus can be combined with